Hello, and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 23. So question number 23 says, solve for x, and we've got an equation, and we just need to try to get x by itself. So by this point, you have solved plenty of different types of equations. You've solved linear equations, you've solved quadratic equations, you've solved trigonometric equations, we've solved logarithmic equations. So you want to sort of take a step back and sort of ask yourself, like, what type of equation is this? Okay, because even though big picture, right, you're still trying to just get x by itself. The way that we go about that is going to be different depending on sort of, the type of equation that you're trying to solve. So this is an exponential equation. Notice that the thing that I'm solving for, x, is in the exponent. All right. So you want to be able to recognize that this is an exponential equation. And if we're solving an exponential equation, our sort of intermediate goal, like to set ourselves up to be able to answer this question, our intermediate goal is to get our equation to look like this. And x is going to be somewhere in that denominator, in the exponent, right? So what I want to get is I want to get something to the something equals something, all right? And that the exponent is going to have an x in it, right? But my point is that what I want on the left-hand side, or the thing that's got the exponent, I just want the entire thing to be raised to some exponent, and then that's going to equal something else. And once we achieve this goal, I'll then explain sort of why this is our goal, okay? But this is sort of this is where we're trying to get to right now. So if I take a look at my current equation, we've got 3 times 10 to the 2x plus 3 equals 60. So we are not yet at our goal because this 3 is not being raised to our exponent, right? If you think about PEMDAS, right, the exponent comes before multiplication. So you're taking your 10, you're raising it to the 2x plus 3, then you're multiplying by 3, right? And that is not what our goal is. Our goal is to take the entire thing, and then that should be raised to an exponent. So I basically have to get rid of that 3. I don't want it there, okay? So it's 3 times. So in order to get rid of it, I can just take my entire equation, okay, and I can divide by 3. Because what's going to happen is on the left, the 3 is going to go away. Great, that's what I want. I don't want that 3 there. Okay, so on the left-hand side, we've got 10 to the 2x plus 3 equals, and on the right-hand side, we've got 60 divided by 3. Well, 60 divided by 3 is 20. So now, sort of compare my equation to my goal. And we have now achieved our intermediate goal. We're not done, but we have achieved our intermediate goal of getting something to the something equals something. The reason why that's our goal is because we're trying to solve for x, which is in the exponent. Unless I get really lucky with my numbers, that's going to be very hard to do as long as x is still in the exponent. Okay, it's not impossible, but with this question and with most exponential equations, solving for x when x is in the exponent, again, the only time you can really do that is if you get lucky with the numbers, and we did not get lucky. So what we need to do is we need to get that x out of the exponent, okay? Because as long as it's in the exponent, we can't really do much with it. So I want to get it out of there. I want to get x out of the exponent. We've now seen this several times where when you have an exponential equation like this, it can be rewritten as a logarithmic equation, okay? So let's try doing that. Let's try taking this exponential equation. We've now done this several times in this assignment, and I want to rewrite it as a logarithmic equation, and you're going to find out why we're doing that in just a second. So I want the log. So 10 was my base. In my original equation, 10 was my base that was being raised to an exponent. So that means it's going to be the base of my logarithm. So it's going to be log. Now, I guess technically I don't even need to write the 10 because that's the common logarithm. I'm going to write it for now just to make it abundantly clear sort of what's going where. And then I'm probably going to drop it in the next step. Because again, when the base of the logarithm is 10, you actually don't need to write it. Okay, so I'm going to write it for now and then it's going to go away. So it's the log base 10, so the common logarithm. And then the argument that goes into the logarithm is the result of the exponentiation, which was 20. So I took 10, I raised it to 2x plus 3, and I got 20. So when I express it in logarithmic form, 10 is my base, and then 20 goes into the logarithm. And then that's going to equal my exponent. Okay, so when you have a logarithmic equation and you say, log of something base something, and then whatever that equals, that is your exponent. So my exponent was 2x plus 3, so I'm going to say that this equals 2x plus 3. Okay. Now, if you don't see what we just did, pause for a second, because hopefully you can now recognize that, before we were in a bit of a jam because the thing that we wanted to solve for, x, was in the exponent, and that's kind of hard to manipulate. But now look at where it is. It's like a quote normal number. It's down. It's no longer in the exponent, and so I can sort of manipulate this equation now without too much difficulty to try to get x by itself. All right. So I'll rewrite it and I'll flip it and I'll get rid of my 10. So we'll just keep everything the way it is. 2x plus 3 equals the log. Now, I'm not going to write the 10 anymore because we don't need to, because it's the common logarithm. So I'm just going to say log of 20. All right, so again, all I did there was I just flipped it and I dropped my 10. I want to get x by itself. Well, don't overthink this, right? Don't let the logarithm confuse you. The logarithm's on the right-hand side of the equation. It's already separate from the x. So all you really need to do now is just focus on getting x by itself on the left, which, fingers crossed, we know how to do this, all right? So the first thing you want to do is you want to subtract 3. So that cancels, and we're left with just 2x, right? So we're close. And then that equals the log of 20, okay? And we'll just make it abundantly clear that it's just the log of 20. And then we're subtracting 3 from that, all right? Again, I want to get x by itself. So we're going to divide everything by 2. So x equals the log of 20, okay, minus 3 divided by 2. And that is my answer. Okay, and that is my exact answer, but probably not a bad idea to also give an approximate answer. So that is my exact answer, but it's also fairly unwieldy. All right, so we want to get an approximate answer. So you just want to be careful about how you sort of type this in. So if I want to type this in, okay. So again, what we're doing is we're typing in the log of 20 minus 3, and then all of that divided by 2. All right. So you can either do this in one step or you can do it in 2 steps. If you do it in 2 steps, well, log is over here. Now, again, this is log base 10, so it's the common logarithm. So you actually can use the log button on the left and just type in just log, right? Because we kind of got, quote, lucky here in that our base is 10. So you can just use the common logarithm button, which is next to the 7. So log of 20. Now you got to close parentheses there, okay? Because the log, it's just log of 20, right? And then once you get the log of 20, then you subtract 3, okay? So that's going to be our numerator. So I'm going to just figure out what is that, okay? That's that. And then I want half of that, giving me negative 0. We'll say 85, I suppose. Quick note: if you wanted to do it in one step, you would either need to use the fraction bar, which my emulator here does not have, so I actually can't. I think it's over. I forget where it is. It's like somewhere in the top. It's in green. I don't have that option, so if I want to do this in one step, I need to introduce a set of parentheses around the numerator like this. Okay, again, close the parentheses on the log, minus 3, close the parentheses on the numerator, and then divide by 2. Okay, so if you want to do this in one step, you need to include the entire numerator in parentheses. Otherwise, the calculator is not going to do PEMDAS correctly. Okay. And then just as a quick side note, again, because our base was 10, I could use the common logarithm button. If the base wasn't 10, and assuming I don't know the change of base formula, which at this point I don't think many people know the change of base formula, you can use a different base for your logarithm, but you have to go under Math, and then you have to go down to option A. So you can either just press alpha A or just go down to where it says log base. All right. And then that gives you the option to do a log with a different base. You just have to kind of find it under the Math menu. Again, it's option A under the first menu under Math. And then you can do whatever logarithm you want. I'll just arbitrarily do our 10 here, and then our 20. And you can see we get our, and then minus 3. My bad. I was like, why did we not get it? There you go. And then divide by 2 gives us our negative 0.85. So we'll go back here, full screen. So this is our exact answer, and then our approximate answer is negative 0.85, and that is our exact answer is the log of 20 minus 3 over 2, and that's approximately negative 0.85, and that is how we solve exponential equations. Question 23.